Ever pondered over the intricacies of the USB circuit in your iPhone 7? This small but mighty technology, nestled within the confines of your handheld device, is a marvel that often goes unnoticed. It's a minuscule universe of carefully constructed components that lie at heart of your device, silently fulfilling their duties every time you plug in a charger or connect a headphone. Today, we're diving deep into this fascinating world, unraveling the complexity that lies within. The USB circuit, an intricate network of delicate components, functions in perfect harmony to deliver uninterrupted connectivity. It's akin to an orchestra where each musician plays a critical role, and together they create a symphony of seamless communication. The USB, a key player in this orchestra, is the conductor. This microchip, minute as it may be, is the nerve center of the operation. It recognizes when accessories are plugged in, it transmits USB data, and converts digital audio data into signals your device understands. This vital component is the linchpin that holds the system together, ensuring communication flows smoothly between devices and your iPhone 7. The dock connector, another important element of this intricate circuitry, serves as the vital bridge. It forms the link between the USB IC and the dock flex, enabling the connection and ensuring that data flows smoothly. It's the unsung facilitating conversation between the various components, enabling them to work together in flawless harmony. Next up is the CPU, the heart of the iPhone, which oversees the entire USB circuit. This vital organ of the iPhone, much like the human heart, ensures the smooth operation of all components. It's responsible for the entire process, coordinating the different elements and ensuring everything runs as it should. The Power Management Unit, PMU, often overlooked, is the lifeblood of the device. Its role in the circuitry is to ensure a steady power supply, allowing the various components to function without a hitch. It's the constant power source, ensuring that all the integral parts of the USB circuit continue to operate flawlessly. Every component plays a vital role in the grand scheme of your device's functionality. Despite being largely unnoticed, it is an awe-inspiring marvel of technology that plays a crucial role in our everyday interactions with our device. Today, we're unveiling the mystery behind it. The USB circuit in an iPhone 7 is a delicate network of components, all working in unison to deliver seamless connectivity. The main orchestrator of this connectivity is the USB IC, the brains of the operation. This tiny chip is responsible for identifying accessories, transmitting USB data, and converting digital audio data. The dock connector serves as the bridge between the USB IC and the dock flex, enabling the connection. The CPU, the heart of the iPhone, oversees the entire USB circuit, while the PMU ensures a steady power supply. So how does this complex circuit function? This is a question many people ask, and a pertinent one, considering our increasing reliance on technology. When you press the power button on your iPhone, a fascinating sequence of technological events commences. The Power Management Unit, or PMU, immediately dispatches a dual-voltage power supply to the USB interface circuit, or USB IC. These voltages are precisely 3, 0V and 1, 8V, triggering the intricate activation procedure. This activation process is not just a simple wake-up call, it's a well-choreographed ballet of signals and responses. The PMU sends a distinct activation signal to the USB IC, a signal likened to the conductor's baton initiating a symphony. This causes a chain reaction, with the USB IC now initiating a power-on self-test via the I2C bus, a process akin to a system health check. If this health check fails, your iPhone will stubbornly refuse to pass the Apple logo, leaving users in a frustrating limbo. After the successful completion of the self-test, the USB circuit undergoes a transformation. It switches to standby mode, a state of readiness and anticipation. Plugging in your phone then acts as the trigger, activating the detect pins residing on the USB IC. These pins act as a sentinel, notifying the integral circuit of any external accessories. Subsequently, the IC sends a rapid interrupt signal to the Central Processing Unit, or CPU. This alert serves a clear purpose. It notifies the CPU that an external accessory is connected and awaits processing. Simultaneously, the IC sends a host reset signal to PMU. This signal kickstarts USB-related tasks, marking the initiation of a new series of operations. The PMU then provides external accessory power to the USB IC. This power supply undergoes a conversion to a more specific voltage range of 268V, 4, 3V, depending on the requirements of the situation. After this conversion, the is released via the accessory detect pin 1 or pin 2. The external accessory then communicates with the CPU through the USB IC, sending verification and device info to the CPU for validation. This process of validation is a sophisticated exchange of information. Once the CPU the connection, data transmission can commence. It is indeed a marvel how such a complex circuit functions with such efficiency and precision. Data, such as images and videos, start their journey from the external accessories, embarking on a path of intricate digital transformation. These pieces of information, initially resting in your camera and other external devices, launch into a complex journey, passing through the USB IC via the dock connector. This is an essential intermediary step that enables the data to traverse the digital landscape in your device. The dock connector, a key component in this process, acts as a bridge. It facilitates the movement of data from the exterior world to the innermost regions of your device. Acting like a gatekeeper, ensures the data that entered is the data that was intended, verifying the integrity before the next stage of processing. Once the data has traversed the dock connector, it is then processed. This is a crucial step that involves converting complex data sets into understandable formats. It's like a translator of sorts, taking in one language of data and outputting it in a language the CPU can comprehend. The CPU's job is to interpret this data and command necessary actions based on the received information. As for digital audio data, they follow a slightly different path. They are usually outputted from the audio IC to the USB IC. Think of it as a direct highway leading the audio data to its destination. The procedure is such that the audio IC hands off the digital audio data to the USB IC, almost like passing a baton in a relay race, which then sends it via the USB cable, an express line to the CPU. The Lightning connector, a unique piece of engineering, is designed with pins on only one side. Depending which side the Lightning cable is functioning, the phone adjusts the pins on the Lightning connector accordingly. It's a dynamic and smart design, adjusting to the situation to ensure the best possible connection. However, it's not immune to issues. For instance, if there's pin damage on the Lightning connector, resulting in failure of the Lightning cable on one side, a simple yet effective solution presents itself. Simply plugging in the opposite side of the Lightning cable can solve the issue. This clever design workaround ensures your device stays connected and functional, even in less than ideal circumstances. Diagnosing and maintaining the USB circuit involves first replacing the dock connector and USB cable. This delicate process begins with obtaining the required tools before carefully removing the old dock connector and USB cable. It's essential to remember that these components are incredibly fragile and must be handled with utmost care to prevent further damage. Once the old components are safely removed, the new dock connector and USB cable can be installed. This isn't just a matter of plugging them in, but rather it requires precision and knowledge of the device's internal operations. One must ensure it is connected properly to avoid any possible errors or malfunctions later on. Following the replacement of the dock connector and USB cable, we move on to the next crucial step. A thorough inspection of the logic board is necessary to whether the USB relevant area is normal. This involves examining each element of the board, observing the overall condition, and making sure there are no visible signs of physical damage or corrosion. The logic board acts as the central nervous system for the device, hence its importance in this process. It's here that the USB communicates with the rest of the device, making it vital to ensure everything is in perfect working order. If everything appears normal, the next step is to run a diode mode measurement of the USB circuit relevant pins on the dock connector. This important step helps identify any abnormalities or malfunctions that might not be immediately visible. This sophisticated process involves careful handling of the connector pins, which require meticulous attention and accurate readings to ensure the correct functionality. Every step taken here requires a high level of precision and knowledge, as the smallest misstep could result in serious consequences for the device. This process emphasizes the complexity and sophistication of the technology that we often take for granted. So, there you have it, a comprehensive breakdown of the iPhone 7 USB circuit, a marvel of technology working tirelessly behind the scenes to keep our devices connected and our lives in sync.